Today we're going to start a brand new tutorial series in how to make an online first-person shooter in Unity using Photon Fusion. It's going to have graphics better than you ever seen before. No, let's be serious. It will look pretty bad, but we will cover the network basics and how to get a first-person shooter up and running. So I've set up Unity and I'm using Unity 2021.3 LTS. And I've also installed Fusion, and the only thing I've done so far is actually to provide an app ID for the Fusion, which you can download or get for free from their website. So if you're using my key, then you might get into trouble because other people might be using it, or I might be working on the sample. So please use your own key, but as a test you can use this from the sample. So what I've done except for that is to provide a simple scene with a few objects, something called ground that has a box collider and some cubes that we can jump around on. And I created this little dude, which is going to be our character. And it is only based on a sort of model that I created. Well, it's not really a model. I've used the primitives in Unity. So it's just a cylinder with some eyes on it, and no colliders are enabled. And I've also added a character controller, which we will be using, and a camera. So this is going to be our FPS camera that we are using when walking around with the character. So that's our basic setup. So the first thing we're going to do is we're going to make a prefab out of this network player PF. So let's select our prefab folder and just drag and drop it here. I've also created a folder called scripts, and in it I have some empty folders. And we're going to start with the network because that's the fun part, right? So we're going to get our character to move and jump and be able to walk around in the world in an FPS style. So let's get started with our core part, which is going to be our network runner handler, because network runner is the heart of how Fusion works. So let's get started with getting that up and running. And let's open that in Visual Studio. So the first thing we can do is get rid of our update function because we won't be using that. And then we need to start using a few things. So we're going to use Fusion, Fusion.sockets, Unity Engine Scene Management, System Threading Tasks, System, and System.link. Awesome. So then what we want to do with this network runner handler is actually to start our network runner. So let's include a public network runner, and we'll call it network runner prefab. So this is going to be referenced from the Unity inspector. And then once we have actually started it, we want to have a reference to it. So let's just do network runner. So in our start method, the first thing we want to do is instantiate a copy of our network runner prefab and put it, store it as network runner. And after that, let's just rename it so we have a friendlier name of it. Okay, so now that we have instantiated it, we also want the networks to start running right away. So what we do is we're going to do the regular startup for Photon, which is from a virtual task. So we're going to do a virtual task called initialize network runner. And it's going to take a few arguments. We're going to feed it with our network runner. We're going to feed it with a game mode, what type of address we want to use, the scene reference, and some event here, action network runner initialized. So the first thing we need to do in here is to check if there are any Unity objects that we should consider. And that is Unity objects with colliders on them, so that the network should react to them. So what we will do is we'll create a new variable, scene manager, and we will get components from the runner, and we're going to get the iNetworks scene manager. So this is different for Photon Fusion 1.1. In the Photon Fusion 1.0, it's called a scene network provider instead. So if you're using 1.0, then you need to change this. Okay, so now that we have done that, we need to check if it is if we have gotten the component, because in our case we haven't added this component to the scene. So let's check if it is null. So if scene manager is null, and in that case we are just going to add it. So if it is null, then we are going to say that, okay, the runner, let's add the component network scene manager default. Okay, perfect. So now we know that we have a scene manager. Then we're going to say that, okay, our runner, we want to provide input, so let's set that to true. And then we want to start our game. So we do runner start game with the new start game arguments, and we just provide the same arguments as we have provided in our function. And then we will provide it with the scene manager as the last argument. Okay, perfect. So now what we need to do is as well, we need to run this code. So in our start function, let's call initialize network runner, and with our network runner, and we will set the game mode to auto host or client. That means that the first when the game is starting up, and if there is no host, then the first client that connects will also be the host. Okay, and then we provide it with the scene manager, get active scene, and build index. And then just let's add a debug log so that we know what's going on and we can see that the server has started. So we'll do server network runner started. Okay, perfect. So that will work now. Let's save and go back into Unity. And then we can create a empty game object. Let's call it network runner handler, and let's just reset the position. Reset so it's at 0, 0, 0. So I like it when it's on 0, 0. It doesn't have to be, but let's have that. And then we'll include our network runner handler, and we need our network runner prefab in this case, which we haven't created yet. So let's fix that by creating a new empty game object, and we will call it network runner PF because it's a prefab, and we can reset the position as well. There we go. And then under prefabs, we just drag and drop it here. So we get a prefab, and we can delete that one. Now in our network runner handler, let's drag and drop our network runner prefab into this slot. But as we see, it's not accepting it. And the reason is because we haven't added anything here. So in our network runner prefab, let's open that, and let's add our network runner. So now we get this nice red saying that, okay, this is a Fusion script actually. And let's just save our prefab and try it again. So now that we have sorted that, let's drag and drop our network runner prefab into the slot, and we can save and take the game for a spin. So now that the game is starting up, we can see that, okay, we have our character. Some things have been added to do not destroy and load, and that's done automatically by Fusion. And if we look at our console, we can see that, okay, we are getting our server network runner started, which is great. And then we have some errors saying 2 audio listeners is in the scene, which is fine because our character has an audio listener and our main camera has that. So we fix that later. But we have some errors. So Fusion is throwing some type of error, and it's saying that, okay, the type controller prototype has not been viewed. And this is something that I've noticed in Photon Fusion, that this is a weird error, and it says that, okay, have you added it, the C# assembly been added to the network config? And that's not the reason for this error. So the reason is that we haven't added a package that is required, and that is actually this one, com.unity NuGet mono Cecil package. So if we exit our play mode and we go into Windows, and then we go to package manager, and it's actually started out in my other screen. So here we go, fetching packages, and let's do what they suggest in the documentation. So we're going to add a package from the git URL, and then we're going to provide the URL that the documentation says, com.unity NuGet monoCL, etc. And we press add, and then it's saying, okay, please wait, installing package, and it will actually stay this way forever. Or actually, now it threw an error. So looking at this, we can say that it cannot perform the operation because it's unable to add the package. And actually, Photon Fusion is trying to do this automatically by itself. And the reason why it's not working is because it is the wrong package. It's not called that anymore. So if we look at add package from git URL and we type in com unity.new get mono Cecil at 1.10.2 and we press add, then it's actually going to install it. So the documentation in Fusion is not updated and not correct, and that's why we're getting this error. So let's skip forward until that is installed. So now we can see that the mono Cecil is actually installed. So we can close our package manager and let's press play again. And now the problems should be gone. So we're saying that, okay, server network runner started, and we actually have under do not destroy and load, we all of a sudden have our network runner. And it is in the state running, and it's in the game mode host, which is expected. And well, there is a local player called 9 active players 1. So that's awesome. Now we have actually gotten our network up and running. Now the game isn't that interesting because well, this character that we have is actually not networked. So the network player PF here, he's not really reacting to anything and you can't control him. So let's make this little dude networked enabled to start with. So let's exit our play mode, and we will start with a spawn manager that's going to be handling the spawning of network objects. So let's create a new C# script and we'll call it spawner, and let's open that in Visual Studio. So the first thing we can do is get rid of our update function because we won't need that. Then we need to add a couple of using statements because we're going to use parts of Fusion. So let's add using Fusion, fusion.sockets and system. And this class is not only going to derive from mono behavior, but also from iNetwork runner callback. So this generates a bunch of errors because we need to implement a couple of events. So let's get started with adding those. So the first event that we are going to get is the on connected to server. And we just do a debug.log so we see that it has happened. Then we have a bunch of additional ones that we need to add that are currently is not interesting for us, but let's add some debug logs on shutdown, on disconnected from server, and on connect request and connect failed, so that we can see what is going on. But all of the other ones we can just leave as empty for now. But we still have an error, and that is because we're missing two of the important ones. So we need to handle the one called on player joined. So let's add our on player joined, because this is what's actually going to spawn players in the world. So for us to be able to spawn a player, we will need a prefab for it. And we will actually add this as a class later, network player, but we will reference it for now and say that, okay, we're going to need a network player and we're going to call it player prefab. So when a player is joining, and if we are the server, then we are going to say that, okay, we have received an on player joined, and we are the server, so we're going to spawn a player. So then we do a runner.spawn, we feed in the prefab that we have here, and the second part of the spawn is actually a position. And we're going to create a new script as well called utils, where we get a random spawn position, and then we're just feeding in well, the quaternion identity, so the player's always going to face forward, and then we need to fit in our player reference that we are getting in this event. So that's a really important one that we need to handle on player join. Another one that we need to handle as well is when we are going to send or receive input. So we will be asked, okay, on input, this event is going to trigger, and in this case we actually have to collect our input and send it to the network so that the host can take care of it and actually act upon it. But we will add that in a little bit later. So let's just save this and go back into Unity. So in Unity, let's fix the first problem and create a C# script called network player, and then let's open that in Visual Studio. So the second error we have is that utils does not exist. So let's create our utils scripts. Let's go in this utils folder, create a new C# script, call it utils, and let's open that in Visual Studio. So our utils class is actually going to be a static class instead. So let's make it a public static class, and we don't need mono behavior for this, so let's get rid of that. And we want to be able to get a random spawn point. So let's add that as a function, public static vector3 get random spawn point, and it returns a random vector that has a position between -x20, positive x20, z -20 and 20. So that's in our world and it's not going to fall off the edge. So let's save that and get back into Unity. Then we need to create a new script. So let's go into network and let's create a new C# script, and it's going to be a network player. And then let's open that in Visual Studio. So let's get rid of our update function because we won't need it. And then we want to be using Fusion. And this network player is not going to be deriving from mono behavior. It's going to derive from network behavior instead. And it will also use iPlayerLeft. So now we get an error because we haven't implemented the player left event. So we need to do that before we can proceed. And but before we do that, let's handle another sort of event, and that's the player spawned. So let's do a public override void spawned. So this will be called when the player is spawned. And what we want to check first is if we have input authority. So if we are controlling this object, that means that we have input authority, then we'll run this code inside. Because if we don't check this, it will run on every client. So let's check that we actually have input authority. And then we will add a new public static variable just to make it easy to find our network local player. So when we have found that we have our input authority, that means that we are the local player. So let's store this as a reference, local player, and then we can fetch it much easier later on. And then we'll add it to the debug log that we have spawned the local player. If we are not the local player, then it means that we are the remote player. So let's add that to our log that we have spawned the remote player. And then we need to handle when the player is leaving. So for that, let's just add a player left, and it will contain the player ref of the player. And if it is the object has input authority, meaning we are the local player, then we want to despawn it as well. All right, perfect. So let's save that and go back into Unity. So if we select our console, we can see that, okay, the window is clear. We don't have any more errors. Perfect. So now we can proceed with actually network enabling our player. So let's open his prefab. And the script we want to start using is our network player. So let's drag it in there. And then it says, okay, this network behavior requires a network object. And there's a nifty little button here called add network object. And then it says, well, the prefab needs to be re-imported. So let's actually save it before that. And then hit re-import, and some type of error does not exist. So that's fine. And we can just leave this for now and see why it hasn't been baked yet. It says this object has not been baked yet, save the scene or enter play mode. Okay, so let's save the scene, and now we got rid of this error. Okay, so that's all good. Let's delete our player prefab, and then we have network runner handler, and that is going to launch or spawn our network runner, but it's not going to spawn any characters yet. So let's open our network runner prefab and add our component the spawner to this. And it will take in a player prefab. So let's go and drag and drop our player prefab in there. And then let's save the scene once more and hit play. And hopefully we should get a player getting spawned when the game is starting up. So we can see it. Okay, so we have some type of problem. The network runner has started, but the Fusion has thrown an error saying that, okay, the prefab network player has not been added to the object table. Usually you don't get this error, but I've been fiddling around a little bit back and forth while recording this video, so obviously Fusion is not able to find my object. So let's hit rebuild object table, and that is going to take a little while, and once that is completed we can push play again, and hopefully it should have now found our little object so we can actually get a player spawned. All right, perfect. So here we have our first person shooter, and as we can see, we're actually inside our character. We can see the eyes, but we can't move or do anything. If we look at our scene and we zoom out, we can see that, hey, we have our little dude. He's spawned right here. So that's fine. That's perfect. That's what we wanted. So let's exit play mode. So now we want to be able to control our character. So what we have so far in our network player prefab is that, okay, we're using a character controller, which usually works pretty well. But with networking, we actually need to adapt this a lot. Luckily, if we look at Photon, they already provided sort of a working network solution for this. And if we go in Photon and then we look at, actually, where are we? Let's go in scripts, and then we have prototyping, and in here we have a network character controller prototype, which is actually a network version of the character controller. But we're gonna make some changes to this. So let's copy this script, and to make sure that, well, if we're updating Photon later on, it's going to rewrite our updates. So let's move that or copy it into movement. And then we actually are going to rename it and say that, okay, it's going to be Network Character Controller Prototype Custom. And let's open that in Visual Studio. So let's rename this into Network Character Controller Prototype Custom. That gets rid of all the errors we have. And for now, we're actually going to keep this just as it is because it sort of works, but we're going to adapt it later on. So let's get back into Unity again. And then let's create another script, and we'll call it Character Movement Handler. That's the script that is actually going to control this character controller prototype. And let's open that in Visual Studio. So with this, we want to start actually using Fusion as a start. And we are also going to say that, hey, this is not going to derive from mono behavior, but it's going to be a network behavior. So let's change that. And then we want to reference some components. So we want to be able to move this character. So let's use another component called Network Character Controller. So that's what we will assign to our character. And what we want to do then is in the awake function, let's add an awake. Then we want to, I screwed up my formatting a bit. There we go. We want to actually fetch this network character controller. So let's just use that as a get component because it's going to be attached to it. So perfect. Now that we have that in place, we can actually start to move around the player based on the input. So what we want is we need to add another fixed update over the network. So our update here is actually just going to be triggered locally. It has nothing to do with the network, so therefore we can't use that to move around our character. What we need to do is use our public override void fixed update network method. So in here we can actually do things that is happening across the network. So the first thing we want to do is get network input data so we can move our character. So this is a bit of a tricky part to think about, but how it works is the clients are sending their input to the server, and the server is authoritative and decides what is going on. So in the end, it's the server that is going to move things, and it's on the server that the actual physical simulation is happening. So for it to really work, we need to get that input from the clients. So what we do is then we are checking, okay, is there an input? And there's this function called get input, and it returns a network input data object that we haven't created yet. So let's save this and get back into Unity so we can create this struct. So let's go and select our network folder and create a new C# script, and we're not going to call it new network behavior, it's going to be called network input data, and let's open that in Visual Studio. So we can get rid of our start and update function, and it's going to be using Fusion. So let's add that using Fusion. And it's actually not going to be a class, it's going to be a struct. And it's going to derive from iNetwork input. So with this we can actually start to providing our network input. Now Fusion recommends that, or Photon or whatever we're going to call the company, they recommend that we are going to use like bits to control what is going on, because it is a smaller amount for information to send over the network. But we're going to make this into a simple tutorial and just use vectors and floats. It's larger for the network, but we're not going to focus on optimization right now. You can do that on your own and read through the network documentation. We might get back into this later, but for now, let's use the bare minimum. So we want to have a vector2 movement input that is telling us, okay, what direction is the character moving? Is he moving sort of in the X or Z direction? So it doesn't include any up directions. We can only move around on the plane, basically. Then we are going to say that, okay, we want to know in what direction the player is facing. So we want to have a rotation input, and it's going to be a float because we just care about the rotation around the Y-axis. And then we want to allow our character to jump. So let's have a network bool and the call is jump pressed. Okay, so those are all the methods we need. Let's save that and get back into our character movement handler. So that clears our error, but let's not have a capital letter here. Let's use a small letter. And now we're ready to actually start moving our character. So let's create a move direction vector, and it's going to be based on transform forward. So the direction the character is looking at, and we're multiplying by how much the user is pressing upwards or downwards, so it can go back and forward. But we also want to be able to strafe. So we add the transform right and multiply it with the amount that the user is pressing to left or right. Perfect. So let's take that and let's make sure that it's normalized. So we'll normalize it. And then we can actually take our character controller and say that, okay, we want to move. And we want to move in the direction of movement direction. And then let's make sure that we actually type it right. So network, character controller, prototype, custom, long name, but yeah, it works, move. So now we can move given if we have received any input, which we haven't yet. So this will not actually do anything yet. So let's save and go back into Unity to sort this out. So let's go into our input folder and create a new class, new C# script, character input handler, and let's open that in Visual Studio. Then we want to start to collect input from the user. So let's create a vector2 move input and vector, and it's going to be 0 as a start. And then when we are entering our update loop, as we usually do, we will actually collect our input here. So let's get our move input up and ready. And what we have then is going to have the movement input vector.x is going to take in the input get axis horizontal, and then we do the same thing for the y, and we'll get the vertical input. So now that we actually have received this, we want to be able to tell the network as well that, okay, we have actually received this. And that is something we need to do in our on input that we talked about way back in the past. So that on input is actually going to happen here in our spawner. It is going to get our on input event. But this one is a little bit sketchy, so we need to make sure that it's actually only caught at one place, or actually handled at one place. So we don't want to have it here and here, because that can create problems later on. So we're going to create a sort of a function to expose it. So let's make a public network input called get network input. And in this we are going to create a new struct called network input. And what we want to do is simply assign the different parts that we have collected here. So we have our network data input, and we call it movement input. And that is going to be our movement input vector. And then we are just going to return it. So then we are actually collecting the inputs, all the frames, and as soon as the network is ready and say that, okay, I want to get your input, then we are simply passing that along. So for this to actually start to work, we also need to start to use it. So let's save our character input handler, and let's go into our spawner instead. So in our spawner, we want to be able to access the local player's input. So let's add another component, and we'll call it character input handler, or actually we will use the character input handler. And what we need to make sure is that we are actually fetching it from the right player, because we can't just do it in the wake function here and hope that it works. Rather, we need to check that, okay, are we actually getting the character controller from the correct player? And what we can do is that we can say that, okay, if our character handler is not assigned yet, it's null, and our network player local is not null, so it means that we actually have a local player, then we can say that, okay, our network player local, we're going to get the component character input handler from that, and we're going to assign it to our character input handler. then we need to start using that. So we check again, is the character handler not null? So it's ready to start to be used. And then we will say that, okay, the input is, we're going to set it, and it's going to be based on what we get from our character input handler. Okay, so that should allow us to start to move our character. So let's save and get back into Unity. So now we can take our prefab, let's take our network player, open that, and start using these components. So let's use our character controller prototype, and then we need to use our character controller, and we also need to use our input. There we go. So let's save our character and take it for a spin and see what happens. So now we have created the ability for the player to move and to collect input from the network. So if I press forward, we can see that, okay, I'm running really fast, and then something happened and it flips out. And the reason why this happens is because we haven't set up the component properly. So if you notice that your player is behaving very erratically and just running around like crazy, it means that you have actually missed a step here. So let's go into our network player, and what is happening is that the network character controller is trying to interpolate the target, and the target is set to none, so it will take the whole thing, and that will just make it go crazy because it will move around well, all over the place and jitter, etc. This is the reason why we created a model object below, and it is the model object that we want to interpolate, because that will produce the effect that we want, that it appears that it's lag compensating and everything, while we can still play the game. So let's save again and take it for another spin, and now it should behave more normal, and we can see that, okay, the game is starting up. We see from our eyes, and we can move forward, and when we are pressing the back button, something weird happens and we can't use the mouse to steer. And what is happening here is that the prototype that we are using, the character controller prototype, is actually moving the view around to face the forward direction. And this is not something we want to have in an FPS game. We want to be able to control the view with the mouse, and we want to be able to strafe, so the camera view should not change to our orientation. So let's stop our game and fix that by going into our network character controller prototype. So let's open that. So let's scroll down and find where the movement is actually taking place. So we have the move function here, and the problem is caused by this that says, okay, the transform's rotation is going to be towards the rotation of direction. So we don't want that at all. So let's get rid of that, and if we save and go back into Unity, and if we press play and take our game for another spin, then we should actually be able to strafe, and here we have our dude. We can move to the right and left and backwards, and as well forward. So now that works, but we still don't have any mouse input, and we can see that well, the movement is ridiculously slow, so we need to beef that up a fair bit. So let's stop our game. So let's tackle the first part, that we want to be able to actually move the character around or actually use the mouse to aim. So let's open our character input handler. So similar to how we got our move input vector, we're going to create a view input vector. And what we will do here is we are going to collect the information from our mouse. So as well as we have move input, we're going to have view input. So let's actually start with the view input before we do the move input. So view input is going to be very similar. We're going to use, okay, the view input.x is going to be the mouse X, so this direction. And then we want to be able to move up and down. So we have the Y direction, view input.y, which is going to be the Y, but we're going to invert it. So it's the other way around. So there are a few interesting aspects of this, and that is this, the X vector, when we're moving to the side, actually matters for the other players because they want to see what direction we are facing. But if we're looking up and down for our simple character, that doesn't really matter. The other players will not be able to see if we're looking up and down. So we can keep this as something that just happens locally. We don't have to send that over the network. So when we are capturing this information, and then when we have assembled our movement input, we want to do the same for the view data. So network input data, we already have something called rotation input, and we want that to be our view input.x. So that's going to be our sort of sideways direction. That's how we're going to rotate. And let's just label this as move data so that we have it. So now we're collecting the view data. When the network is asking for it, we're actually going to send the rotation data. But we also need a way of handling the up and down view. So from this, let's actually reference our component directly, our character movement handler. And then we need to get it in our wake function. So let's just cache that. And once we have done that, we need to actually send the view vector to it so that we can handle this rotation. So we're going to add a new function called setViewInputVector, and it's going to take in a view input vector. So let's save that and get into our character movement handler so we can add it on that side as well. And actually, when I think about it, let's fix the jumping while we are at it. So if we are getting the jump button, if that is being pressed by the user, then we need to have a boolean for that, and let's say that bool is jump button pressed. And actually, when I think about it, let's just assign it directly because we don't need to have an if statement for that. So there we go. So if the jump button is pressed, then we are going to use this, and as well here with the move data, let's use jump data, and it will be network input data, and we have is jump pressed, and let's assign that to is jump button pressed. There we go. So now we've added support for jumping as well. Now we can move into our character movement handler. So let's add a variable to handle the viewing part, the view input, and we are going to create a function so we can set that. So let's create that public set view input, and it takes in a view input and it assigns the view input to this. All right, fabulous. So what we want is we want to handle our little camera rotation. So let's fix that. So the first part we want to do is handle up and down rotation. So we're going to call it camera rotation X. So that's our ability to look up and down. And for us to do that, we actually need some other components as well. We need to be able to handle our local camera, because there is a local camera attached to the player. So this local camera, let's get a copy of that. get component in children, and we'll get the camera. Okay, so now that we have that, we can say that, all right, you know what, when we are going to look up and down, then we want to do that in the update function. So we're going to say, okay, our camera rotation X is going to be equal to the view input dot Y times dot delta time. So that makes it independent on the frame rate. And we're gonna just add it to this rotation vector. So as the mouse is going up, then the view will actually go down because we have reversed it. Or actually, no, as the mouse goes up, we will look up. As the mouse goes down, we will look down. So perfect. Then we actually need to handle that rotation as well. But before we do it, we want to sort of clamp it. So we don't want it to be able to go too far. We don't want to like bend our necks. So let's start at minus 90 and 90. So we can look down on our feet and we can look up straight into the air, but nothing more than that. And that also solves gimbal lock problems that we could potentially have. So then we want to actually use this rotation for the camera. So let's go local camera, transform local rotation, and then we create a I can say it now, a quaternion, and we do it from an Euler, and we'll use a camera rotation.x and rotate it in nothing in the other directions. So with this, we will now be able to look up and down, but we cannot look to the sides because that's going to come over the network as we want that as well to show for other players. So how should we handle this? So what we do is we're going to rotate the whole character. So if we look at our movement here, so we are getting the move direction and we are calling a move, which is perfectly fine. And then we want to enhance it as well with the ability to rotate. So we will take our network character controller prototype and we will say that, okay, we are going to rotate, and we're going to do that before we move, and like that. So rotate does not exist yet, so we need to add that in our class, but it will take in a sort of our float that we are getting from the network. So the network handler, network input data should include a rotation input now. So if we add this and we're getting the rotation input from the network, then it will be super nice. So let's have that. And while we're at it, let's add that jump function. So after we have moved, we can handle jump. And it's actually important that the jump is after the move, because the move will change some things, so it won't properly work if we do a jump before a move. So let's use the jump after we've moved. So if our network input data says, okay, it says that the jump is pressed, then we are going to say that, okay, we want to jump. And the network character controller prototype already has a jump, so we don't have to fix that. But before I forget it, let's go back into our character input handler. And as we're using the mouse now, the mouse cursor, we want to do a few things with it. We want to say that the lock state is going to be locked, so it doesn't move outside our window. And we are going to hide the cursor, so we don't see it anymore when we are playing our game. Okay, perfect. So now we can get into our network character with a very long name, network character controller prototype custom, and add our rotation function to it. So let's scroll to our bottom again, and let's add a new function to this. And I'm not super good at commenting, so I'm not really sure why they have messed up the formatting, but yeah, whatever, we'll keep it as it is. So rotate is going to take a float, rotation Y, and it's going to do to rotate the transform around the Y-axis, and we are going to use the runner.delta time times rotation speed. So in that case, we need to make sure that there is a rotation speed, and it already has that. So that's all super good. So let's save that, and let's get back into Unity and try this. Alright, so if we hit play again and let our game load, and then our character will be loaded, and we are looking through its eyes, so it's perfect. And we can rotate the mouse, we can view up, we can move down, and we can move the character. However, everything is super sluggish. It's very slow, and it's not playable in the state, and it's very hard to actually move and view anything. So we need to beef up a few values. So let's start by opening back our network character controller prototype custom. So our network character controller prototype custom already has a lot of settings, but it's missing one, and that's the ability for us to change how fast we look up and down. So let's add that as a... I wonder why it screwed up my formatting. Well, I have to look into that later. So public float, view up down rotation speed is going to be 50. The other ones we can set through the inspector, but we need to start to use this value as well. So let's go to our character movement handler, and in this we are controlling how fast we are rotating. So here we have our view rotation, and this needs to be multiplied by that value. So we have our network, character custom, and then we are using view up down rotation speed. Okay, save, and let's get back into Unity. Alright, so now we can change our values, and I've tried it a few times, and I've changed the acceleration to 50, braking 30, max speed 6, rotation speed 80, view up down rotation speed 60. So let's take it for a spin with those values, and now the controller should be a lot snappier and yeah, more fun to play. So here we go. We can now run around and yeah, move our mouse, and we can look up and down. It might still need some tweaking, but it's a lot better. So there is one little sort of lag problem, or it feels like lag, and that's when I'm releasing the keyboards, it actually keeps on moving. So this is not a behavior that we want. So let's exit our play mode. So this lagging we have when we are pressing the buttons and the characters is continue to move, even though that we have let go the key, is actually not caused by Photon. It is caused by Unity, and the reason is because we have some settings in our input. So let's go into project settings and input manager, and we're still using the old one, but what we have here is horizontal movement, and we have something called gravity. So gravity is a way of simulating like digital or gamepad input, but for a keyboard. But that causes everything to actually be a little bit sluggish and not that fast. So let's just change this into 3000 instead of 3. And vertical, we can do the same for gravity and change it into 3000. Now that I'm letting go of my input keys, it will actually react a lot faster. So again, if we take it for a spin, and I mean, this is a little bit hard for you to see on the video, but it's going to be like instant. I let go of a key like now and it stops. Let go of the key now and it stops. So that's solves our problem. And now we can also try this with, of course, multiple players. So let's compile a few clients and take it for a spin with well, multiplayer. So let's build this. So go into build settings, and scene in build is empty. So we need to add open scene, so it's included, because otherwise the clients will not function properly. Then we go into player settings, and let's change our resolution from full screen window into windowed, and put in some width and height. Perfect. And now we can close this, and let's just press build, and let's speed this up so it goes really fast. So let's take a first spin with multiple clients, and as we can see, we can now join the game, and others can as well join the game. But there are a few issues. We see the eyes of our character when we are looking through our first person camera, and that's not something we want. And as well, we are getting multiple cameras in the scene. So each time a client is connecting, we actually see through that camera, and that's not something we want either. But that's something we will fix in the next tutorial. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. So that concludes the first part of this tutorial series. I hope you enjoyed it, and please give it a thumbs up if you did. And also consider hitting that subscribe button. And also press the bell to get a notification when the next video is out.